Is it recording now? CPU is jumping up. Okay. Seems like it's stabilized, so time to demonstrate some HDAs. So, the first HDA that I want to demonstrate is the box stacker. And I'm going to do it quick this time because I've already recorded this once and I only have a little bit of time left. Wait now. So, what do you do with the box stacker? You stack shit. Go to General. Here's the input geometry. I'm just going to put some boxes. Real quick, jump into the rotation randomization, set it to 0. There we go, 10, 0, 0, and 0. Yes, please. Okay. Then I'm going to bump down the position to 0, 0, 1 and 0.001. And that's going to create a basically perfect stacked box, but I don't really want that. So let's do 0.05. Then you have a very slight amount, not a whole bunch, but enough to give it some definition when you look at any of the faces. You can see a little bit of, naturalness. I might actually increase this just to 0.1. Yeah, there you go. Perfect. See that? Looks a little bit more natural now. And then you can shove that up against a wall or something. Have a bunch of stacked boxes that look alright. And that's that. Moving swiftly forwards, I'm going to go to the curve generator. First thing that's going to need to happen is, I already know this ahead of time, its scale is just going to need to be set to something way lower, like 0.2. This is something I messed up and just don't have time to fix, is that I made the scale of it way too big. I don't really care. Let's just do this quickly because I'm running out of time before class. Because of course I am. Did I put SM tape in there? Oh. No, I meant to put traffic barrel in there. Well, assuming that I put the right one in there, you'll see him pop up, but I might have just accidentally thrown a tarp on there, which will look terrible. Yeah, this is taking a while. Yeah, okay, that's what I wanted to see. Little proxy distribution curve. So I just basically cut it off. Said no, don't do that, please. I'm also gonna reapply just in case, and then disable. Okay, now it seems like it's actually working. Give it a few seconds. There we go. Look at that. Very nice. Well, doesn't exactly look like a bunch of things stacked. But we can change that with the point relax. I'm going to put that up to like 5 for the scale. That's just going to basically make them bigger. P-scale. Point relax is all about the spacing between them, and that'll basically, yeah, do something like that. I don't like the outlier so much, so I'm gonna P-scale to 6 to to 1 and but you know, that's the basic idea. I think of yeah, that looks better. That looks significantly better. Yeah, I think putting the point relax stuff in here is redundant. In the last recording I talked more about it, but it was way too long, so I re-recorded it. Essentially, I don't like how this works, and I've got a tiny little physics-based solution that I didn't have time to fully implement. And let's just take a real quick look at that. Just real quick. Now that I've already demonstrated the two things that I need to demonstrate about that. The two HDAs is that they work in Unreal with, you can just drop input geometry in and they'll function. Oh, this is just a little demonstration of proxies in this one. I've already shown proxy off in that one, where it just basically gives you the rough curve. But yeah, for this one, as you can see by how long that took to load in, complicated shapes take a lot more time to copy. So you're going to want to like position them first, then figure out what you want to do with them. So there's a proxy for this, and there's a proxy for this, if I can find it. Should be under curve, yeah. So basically you just take a look at the raw curve itself of, you know, basic, a rough idea of how the thing will change. Amplitude, you know, does that. Real quick, let's just demonstrate some more stuff. You know, I might have forgotten to demonstrate this stuff ever so slightly, but you know what, screw it. You can change the number of copies, of course, change their internal offset to make them spaced out, change how they randomize, which basically just, this is the positional like offset, and this is how much they rotate, which should usually be 1, 1 or 0, 0, because you know. Is it done loading? It is. So we're gonna take a real quick look at this. Real quick. Come on. This is reducing all the polygons right now. Yeah, that error is to be expected. Okay. So this is the solution that I did not actually get time to implement, unfortunately. I only thought of doing this pretty much in the last week. A little silly of me, but you know, I think it was something that was said during one of the reviews where a physics-based, you wouldn't be able to do something like that without a physics-based solution, and I was like, you know, maybe I'm going about this in a too complex way. Maybe the best solution might be the most obvious solution, which is just to, you know, simulate it and actually make a physical pile. So that's what this does. I'm just going to skip ahead to, because it's slower when the video's recording, so I'm just going to do that. And down here, take a look. I'll probably just, if I remember to, I'll skip ahead in the video, but honestly, I don't have the time. I might just upload this entire video as a single video file, because yeah, first recording, thought that I did it with enough time. As it turns out, everything was moving at a snail's pace and you couldn't see anything. It was all in frames. And it's about, oh, okay. So that is 600 frames of simulation right there. And we can actually go backwards in time faster. Oh, that's only from frame 200. There's a way to increase this. No? There we go. Alright, yeah. So that's basically what we want. And then we leave a couple extra 100 just so that it has time to like relax and settle. And then this would be what we output. Downsides. USD, Universal Scene Descriptor. See, you might have noticed here that this is not a GeoNode, but an LOPNet, which is basically Houdini's way of working with USDs. I don't know if you've ever heard of USDs before, but essentially it's a Pixar-made file format that standardizes a scene, so like a scene hierarchy. Let me actually just open it up in USD Scene Graph Tree. So yes, this is what the scene looks like. And each one of these pieces is a piece of head geometry, and then simulated ground is pulled in through this node, and then the imported objects are pulled in through this node. So this is the ground, and this is the simulated objects. We just simplify the number of polygons, and then do a physics-based drop test on it for however many number of frames. Benefits, it gives you a really, really nice pile. Downsides, it has to simulate the whole thing, and USDs. I cannot, for the life of me, figure out USDs. You're supposed to be able to export them as a single .usd file that you can open up in Unreal, which is how I originally wanted it to be done. I wanted to make an HDA where you import a file, and then it can export USD into the same file location that you put the HDA, or at least somewhere close to it, so that it could be easily found. I can't get it to export. I don't know how. If I had more time, but again, I really just started this new solution to the pile generation recently, which, I mean, I can't even get it to export a USD inside of Houdini, let alone inside of an HDA, so I'm clearly doing something wrong. I really got to spend more time with USDs before I did something like this, and it wasn't something for me to add in during the last week, essentially. So that's why I'm only submitting the curve-based pile generator and the box stacking pile generator. Because those are the only ones that are actually in a state that are, finished. Alright. Still, it would have been nice, though. It really would have been. Especially because you can see it, and if I could find a way to just show that animation and play it, and then the user can stop the animation with a button and then export it, or even just I don't know if there's a way to turn a USD back into geometry, but yeah, I don't know enough about. I looked into it for a long while. I even did some DOP network stuff, which is the other physics-based thing. So you have bullet solvers and gravity and static solvers, but like a similar problem. Well, there's an entirely different array of problems with that one. Long story short, if I wanted to do a physics-based solution, I should have done it earlier. So I'm sticking with the curve-based one. That's it.